Welcome to the lecture on integrals of exponentials and logarithms. Okay, so what we're going to be doing this lecture is, given the function, we are going to integrate, I cannot speak, e to the x and ln x. So what I need you to do is I need you to recall, and my pen, my Apple pen is not working. So I'm going to have to give me just a sec to resync. And then recharge. You know, sometimes technology is just grand. All right. So I want you to recall that the derivative of e to the x is e to the x. So then if I want to integrate e to the x dx, then I get e to the x plus c. All right? So that means that if I have the derivative of e to a function, then that's the derivative times e to the function. So if I have the derivative times e to a function and I integrate that, then I get e to a function plus c. So recall that if I have the derivative of 1 over x, that if I have the derivative of ln x, that's 1 over x. So then if I integrate 1 over x dx, then that equals the natural log of not just x, but I have to put absolute value bars around the x, plus c. Remember that I can only take the log of a positive function. So these absolute value bars are important, and if I don't put them, then I will take off a point. Okay? So if I have the natural log of a function and I take the derivative of that, then I have the derivative of a function over a function. So if I integrate something where I have the function in the denominator and its derivative in the numerator, then I'm going to integrate and I'm going to get the natural log of that function with absolute value bars around it plus c. All right, so let's get to some examples. And they're a lot easier than you think they are, okay? Don't be scared. So if I have 1 over x, so first thing we're going to do is we're going to rewrite this. The 1 over x, because remember, ln x, the derivative of ln x is 1 over x, so I'm going to leave that alone. So that's 1 over x. I leave alone e to the x. This term I'm going to rewrite as x to the negative 2 plus x cubed dx. Now I can integrate. So I'm going to get ln, absolute value of x, plus e to the x. Here, I'm going to add 1. So that's x to the negative 1 over negative 1 plus x to the fourth over 4 plus c. This right here is the only term I need to simplify. So that's ln, absolute value of x, plus e to the x, minus, and I can rewrite this as 1 over x, plus x to the fourth over 4, plus c. And this will be my final answer. All right, this is considered to be a u substitution. So I'm going to let u equal 7x. Then du equals 7 dx. Now, a lot of people notice that right here I have that. Now so a lot of students will say, okay, well then you can just do this and you can go straight to this is e to the u, integrate e to the u, and go on. Here's my advice. Follow my steps. if you follow my steps, even though you may see the pattern and you may see that you can go on straight to the e to the u, for the next question where it doesn't have the identical answer, then you can still work it. Okay? You're just adding an extra step into it, but it'll fall out if you follow my steps. Go ahead and solve this for 1 over 7 du equals dx. This will be e to the 7th x, 7, I don't want to do it that way. Sorry, guys. So this is going to become the integral of 7 e to the u times 1/7 du. Okay. Then the 1/7 and the 7 make 1. So what I'm really integrating is e to the u du. So that's e to the u plus c. So this becomes e to the 7x plus c. Now, if you can go from the original to the answer, then go from the original to the answer. It's fine. Okay? Here's my warning. For the next one, where it's not as easy, I don't want you to run into trouble. Okay? So let u equal 1 over, let u equal 0.1x. Then du equals 0.1 dx. So 1 over 0.1 du equals dx. So this is equal to 10 du. If you do this multiplication or division, this right here equals 10. Then going back and substituting stuff in, I get this is the integral of 8,000 e to the u times 10 du equals 80,000 e to the u plus c. So that's 80,000 e to the 0.1 x plus c. So my problem is that for the first one, you could see the 7, For the first one, you could see the 7 and you could see that it was there. For the second one, it's not as obvious. Okay? And my thing is messing up. And so I don't know how to get out of that. Okay, there we go. All right, so it didn't save that last one. So let's go to the next one. All right. So most of these are going to be U substitution because that's where most students struggle. All right. So this is U equals negative 0.8x. So then du equals negative 0.8 dx. So that's 1 over 0.8 du equals dx. All right. So that makes it be, this is actually negative 5/4 du. All right. So when we substitute this in, we get the integral of 960 e to the u times negative 5/4 du. So that gives us negative 1200 e to the u plus c, and that's if we simplify those fractions. So that gives us negative 1200 e to the negative 0.8 x plus c. Okay? All right. So here, u equals 2x cubed. So du equals 6x squared dx. So 1/6 du, that's a 6, equals x squared dx. So we have the integral of e to the u equals 1/6, that's a 6, du. So we have 1/6 e to the u plus c. So that's 1/6 e to the 2x cubed plus c. Right? Now, for this one, we want to rewrite it first. So we get 7e to the negative 9x dx. So then u equals negative 9x. So then du equals negative 9 dx. So then negative 1/9 du equals dx. So we have the integral of 7 e to the u negative 1/9 du. So that's negative 7/9 e to the u plus c. So that equals negative 7/9 e to the negative 9x plus c. Okay? All right. Now we have something a little more complicated, but you want to rewrite it first, all right? So this is the integral of x to the 7th e to the negative parentheses 5 minus 3x to the 8th dx. All right, now distribute that minus sign. So you want to distribute this minus sign through the parentheses. So that's the integral of x to the 7th e to the negative 5 plus 5. Sorry, that's not a 5. 3x to the 8th dx. Okay, now you want to let u equal negative 5 plus 3x to the 8th. Then du equals 24x to the 7th dx. So then you have 1 over 24 du equals x to the 7 dx. Right? Now you substitute. So you have the integral of e to the u equals 1 over 24 du. So that equals 1 over 24 e to the negative 5 plus 3x to the 8 plus c. And I just did multiple steps at one time. So you would have a middle step here of this is 1 over 24 e to the u plus c. Sorry, guys. Then you go back to your original variable. My too much calculus is getting ahead of me. Okay. So now let's go here. So we're going to have two different variables for number 8. All right. So we're going to let, this is going to be 1. So first let's rewrite the second term. So this is going to be the integral of e to the 9x minus 6 e to the minus x over 2 dx. All right. So here, you can separate these into two separate integrals. And so, but what I would do is I would let this be u equals 9x and let this one be v equals minus x over 2. So then du equals 9 dx. So you have 1/9 du equals dx. And here you have dv equals negative 1/2 dx. So you get negative 2 dv equals dx. All right, so you have two different sets of u substitution. So you're going to solve this one side and this one side as two different integrals. So you're going to have this equals the integral of 1/9 e to the u du minus the integral of 6 e to the v times minus 2 dv. Okay? So that equals 1/9 e to the u, combine the minus signs, plus 12, combine the 6 and the 2, e to the v plus c. Now you only have one c because a constant plus a constant is a constant. All right, so the constants just add together. So this equals 1/9 e to the 9x plus 12 e to the minus x over 2 plus c. And so that would be your final answer. So realize that when you're doing these, when you're integrating anything, you can integrate term by term in the same way that you can differentiate term by term. All right? Now, I'm going to call this done. Now remember at the very beginning of this section that we talked about that the integral of 1 over x dx was equal to the natural log of the absolute value of x plus c. Now we're going to use that, but now we're going to have a function. Okay, so now I'm going to draw a little line here because now we're doing the other half of this section. So we're going to have that u equals 2z plus 7. So then du equals 2 dz. Okay, there's my dz. So then I have 1/2 du equals dz. So now I'm going to substitute. So this is the integral of 1 over z times 1/2 mistakes abound. 1 over u times 1/2 du, because this is u and that is 1/2 du. So the 1/2 is a constant, so I'm going to pull it out in front. 1 over u is ln absolute value of u plus my constant. All right, so this got pulled out. This is the natural log, and then I have my integration constant. Now I'm going to go back to my original variable. So that's 1/2 times the natural log of the absolute value of 2z plus 7 plus my constant. And that is my final answer. All right, now I'm going to go to the next one. Okay, so u equals x cubed plus 5. So du equals 3x squared dx. Okay, now I'm going to cheat because I see that I have 3x squared dx right there. So this equals the integral of 1 over u du. Okay, so that is the natural log, the absolute value of u plus c. So that equals the natural log, the absolute value of x cubed plus 5 plus c. All right, and that's my final answer. Okay, let's go to the next one. And I'm going to scroll it up a little. Okay, so u equals 4x to the 6 plus 4. So du equals 24x to the 6th. Sorry, x to the 5th dx. So that's 1 over 24 du equals x to the 5th dx. So this equals the integral of 20 times 1 over u times 1 over 24 du. Okay? So this is a tag along, right? So I'm going to put a little, come over here and I'm going to put a little step here. So this is the integral of 20 times 1 over 4x to the 6 plus 4. So that's my 1 over u times x to the 5th dx. So there's my 20, there's my 1 over u, and there's my du. Okay, just so that you can see each little piece. So now I'm going to integrate. So this is 20 over 24. This integrated becomes ln absolute value of u plus c. So that equals 20 over 24 simplifies to 5 over 6, the natural log of the absolute value of 4x to the 6 plus 4 plus my c. And so that is my final answer. Okay? All right. Word problem. Yay! Suppose that my marginal revenue is given by that equation. What is the revenue in dollars from the sale of 100 units of products? All right. So, I have to assume that my revenue of 0 equals 0. Okay? So, r of x equals the integral of mr dx. Or, that's the integral of r prime of x dx. So, r of x equals the integral of 7e to the 0.01x dx. So, u equals 0.01x, du equals 0.01 dx. So that's 1 over 0.01 du equals dx. Which is 100 du. Okay? So this is equal to the integral of 7 e to the u times 100 du. All right? So that's equal to 700 e to the u plus c. So that equals 700 e to the 0.01 x plus c, and that's r of x. Now I put in the fact that r of 0 equals 0, so that's 700 times e to the 0 plus c. Well, anything to the 0 equals 1, so that 0 equals 700 plus c. So then c equals negative 700. So that means that r of x equals 700 e to the 0.01 x minus 700. All right, so then I find r of 100. So that's equal to 700 e to the 0.01 times 100 minus 700. And I plug that into my calculator, and I get 1202 That's a 2, 0.79728. Okay? All right. Now let's look at the rate of vocabulary memorization. Okay? So if I know that, then what I know is I know that v of 0 is 0. Okay? So v of t equals the integral of 40 over t minus t plus 1 dt. So u equals t plus 1. So du equals 1 dt. So this is the integral of 40 over u du, which is 40 ln absolute value of u plus c. So v of t equals 40 ln absolute value of t plus 1. That should be an absolute value. And I know that v of 0 equals 40 ln of 1 plus c. Well, the natural log of 1 equals 0. So this tells me that, and that value equals 0, so that tells me that c equals 0. So then I know that v of t equals 40 ln absolute value of t plus 1. So then I want to find v of 3, so that's 40 ln of 3 plus 1, which is 40 ln of 4, which is a perfectly good answer to me. So what we get is 55.451744. Did that have one more 4 on it? 4. Okay. All right. And we have one more question. Okay. All right, the things you need to know about this one is that p is constant. So that means that p is a number. All right, so s of n is the integral of ds dn, which is the integral of 0.08 p e to the 0.08 n dn. So u equals 0.08 n. So then du equals 0.08 dn. So that's 1 over 0.08 du equals dn. All right. So now when we substitute our variable in, we get the integral of 0.08 p e to the u times 1 over 0.08 du. This and 0.8 and that one cancel. So this is the integral of p e to the u du. Okay, which is p e to the u plus c. So S of n is p e to the 0.08 n plus c. Our initial condition, so at time 0, we initially put in p amount. So that means S of 0 equals p. So S of 0 equals p, which equals p e to the 0 plus c. Right? Remember that e to the 0 equals 1. So that means that p equals p plus c. So c equals 0. So that tells us that S of n equals p e to the 0.08 n. And that is the answer to part A. So for part B, it asks us how long for that thing to double. For part B, this is a 1330 question. So we want 2p to equal p e to the 0.08 n. Divide both sides by p. So we get 2 equals e to the 0.08 n. Take the natural log. Take ln of both sides. So ln of 2 equals ln of e to the 0.08 n. Bring down the exponent. So you have ln of 2 equals 0.08 n ln of e. Remember, ln of e equals 1, so that's ln of 2 equals 0.08 of n. So then n equals ln of 2 over 0.08. And we're done. So the last one was divide by 0.08. All right, so we're done. That's a lot of information. So let me know if you get stuck, especially on any of the u substitution with the integrals. Now, this last part, B, is 1330, solving for an exponent. Most students struggled with that in 1330, so if you have trouble with that, remember the steps. Email me or post on the discussion board if you have any questions. And I said 1330. For it could be it's a laws of exponents question. It's solving for an exponent. So it's not necessarily in the calculus portion of this course or whichever course you're in. All right, so let me know if you have any questions. Thanks.